What's up everyone, welcome to the 9th tutorial in our Pandas course. Now that we've learned how to retrieve elements and properties of series, we'll learn how to modify them. So this could be modifying the values or the general structure of a series. So we'll first cover adding elements to series and removing elements from series, and then we can cover modifying the series elements. So this could be changing individual values or multiple values using slicing techniques. And finally, we'll work on shuffling and relabeling series. So let's head on over to Google Colab now. Alright, so last time we left off in section number 8 that was guessing the series properties. We just want to again make sure that this is running. We haven't disconnected, we can reconnect if we need to, and rerun the cell if you need to as well. Otherwise, we'll get started with a new code cell down at the bottom there. Okay, first thing we'll do is just create a series that we can work with. So this will just be series equal to a pandas series, and I'm just going to actually create this from a dictionary just to mix things up a little bit. And I'm going to use the classic kind of naming convention that we've got going and we've been using so far. That's just going to be A, B, C, D, and E, and I'm just going to assign the values 1, 2, 3, 4, and 5 to them. Okay, so feel free to use something a bit more creative if you want. If you want to use some strings or booleans or floats instead of these integers, that's totally fine. If you want to create your series a different way, that's okay as well. But this will just provide a nice kind of spread so we can demonstrate the techniques that we want. Alright, so we're going to focus on just adding and removing in this section. In the next section, we will work on the reassigning of values, both single and multiple values, and then also modifying the series structure as well. Okay, so first of all, adding items. So we might want to print out what the series looks like just to make sure that we know what we're dealing with. So I'm just going to print out the series here. This is what it looks like. Now that we know that, let's add some items to it. Alright, so the simplest way to add just a single item is by specifying the index or the key that we want and then inserting an item there. So for us, it makes the most sense to specify the key that we want. So what we can do is we can just say series and then whatever new key we want. So in this case, maybe let's do an F. Probably make that a string. Okay. Then I'm going to set this equal to some new values. So maybe we'll do 6. Okay. Then afterwards, we're just going to print the results series like so. Okay, so this is it before the addition, and then after the addition you can see that we've added a new key value pair. So this is going to be the index that we want and then the value that we assign. Just a heads up, if you specify an index that already exists, that's just going to modify it. So in this way it works very, very similar to just a regular Python dictionary, but if there is a new value there, it will create a new entry instead. Okay, so that's all good, but what if we want to add items, multiple items onto the end of our series? So let's say we want to add 3 items at once. Well, for that we can use the append function. Now the append function will work slightly different from doing things this way, because this actually modifies the original series. Note how we didn't reassign it to a new series or anything like that. It's this one that's modified. However, the series.append function will return a new series. So we could say something like new series is going to be equal to our current series, and we're just going to add some items to it. So really we should be appending a series, or I guess that disappeared, a series or a list or tuple of series. In our case, we'll just create a brand new series like so. We can, let's just do another dictionary. So we've already got F, we'll do G, we'll do H, and we'll do I. Okay, so this will just be 7, 8, and 9 respectively. Good stuff. Okay, so let's print out the value of series and also of new series. Okay, so we'll do series there, and we'll do new series. And I think there's no point in doing that, so we can get rid of that print statement. Okay, so this was the series after we added this. Remember, we added the F and 6 to it. But afterwards, new series now looks like this. So even though we added all of this stuff, it gets basically reassigned to a new series. And so new series changes. We get these 3 key and value pairs added, but the original series remains unchanged. Of course, that's with the append function. With this one, it does change the original function, or the original series. Okay? So those are really the 2 main ways of adding items to our series, either by assigning a single value or by assigning multiple values. What about removing items from series? So we can do the removing section now. So there's actually a few different ways we can remove items from series. The first, which is perhaps the simplest, is actually pretty much just straight up Python syntax. So we can do the delete and then whatever row we want to delete. So in our case, maybe we'll delete the very first row. We'll delete the A and then the 1. So we'll delete the series and then we'll delete the series of A. Okay. We can also put the index in here as well if we want, delete series of 0, and that will delete the very first element, but I think in our case it makes more sense to go with keys. Now the difference here is that this will modify the original series. This changes the series, it's deleting it right from this. Okay, so we will notice that modification to the original. Another way of doing this is with the drop function. Now the drop function, much like the append function, actually does not modify the original series. It returns a brand new one with the items dropped. So we could do something like new series is equal to our series, and we're going to drop some items from it. So this will allow us to drop multiple items at once. Let's say we want to drop, again, series is modified. It is missing A at this point in time. Let's say we want to drop E and F. Okay, we can drop E and we can drop F like so. If we print out series, oh, look at that. Well, series remains unchanged. And that is because, again, series.drop will return a new series. So now if we print that and then we print out our new series, we should see this has dropped our E and F keys. Okay? So again, returning new series, changing the original series. Now there's a third way of doing things, and that's with the pop function. The pop function, much like the delete keyword, will actually modify the original series, but instead of returning a new series, it will return the popped value. Okay? I think regular Python lists also have a pop function that does a very similar thing, except it automatically pops off at the end. With the series, we can specify the key that we want to pop, so it's not always coming off at the end. In fact, let's pop off the very first element, which would be B and 2. So we'll do something like series.pop, and we'll do the key B, and actually we can return the value, so we're just going to say popped is equal to this. So now if we print series, and we're also going to print popped, we should see that the original series has been changed, and we're also returning that popped value there, which is a 2. Okay, so that is pretty much actually all we wanted to cover here. We covered a couple ways of adding items and a few ways of deleting items. Again, just to remember, just as a quick summary, this will modify a key if it exists. Otherwise, it will just add the key into the dictionary or into the series here. This will add as many items, basically add an entire series onto the end, but it doesn't modify the original one, it returns a new series. When it comes to removing, this delete will actually remove something from the original series, so it changes that. The series.drop is going to be a way to drop multiple elements and will return a new series that leaves the original one unchanged. The series.pop does affect the original, but it returns a new value rather than a new series. Okay, so definitely play around with these a bit. Make sure you're super comfortable adding and removing elements. In the next section, we're going to be again focusing on these series modification functions, but this will be more on changing individual elements, changing multiple elements, as well as kind of shuffling our series around. Okay, so stay tuned for that. Thanks for watching, and we'll see you guys in the next one. What's up, guys? Welcome to the 10th tutorial in our Pandas course. This is part 2 of our series modification tutorial. In the previous section, we covered adding elements to series and removing elements from series. Now we'll work on the modification side of things. So this could be modifying one or more elements at a time, or shuffling and relabeling a series, so kind of doing a bit of restructuring. So let's head on over to the code now. Alright, so last time we finished off in section 9, that was just adding elements to and removing elements from a series. We're actually going to get started with a new cell because we'll be working modifications. I'm going to just copy over that same series into this next cell. Just a quick refresher, this is what it looks like. Okay, it's just again the labels A through E and the numbers 1 through 5. Cool. Alright, so the first thing we might want to do is learn how to modify single elements. So this will be modifying elements. Well, that is done in exactly the same way as if we were to add a single element like this. We just specify the position or the index label that we want to change and then reassign a new value to it. So let's say we want to change the very first index to a 0 instead of a 1. We could do series at the index of 0, index position 0 is going to be equal to 0. Okay, we'll print out series. And note that the original series is being changed here. So again, much like a regular Python list or dictionary. Similarly, we can access items based on their index labels. So let's say we want to change the last one, which is E. We could do series of E is going to be equal to, I don't know, maybe we'll do 6. Okay, and then we can see that in the original series, that E is now changed to a 6. Okay, so that's cool, but what if we want to modify multiple values at once? Well, for that, it's probably easiest to specify a range or a slice of values that we want. So again, we can use the assigned labels, or we can use positional indexing. So for these examples, I'm just going to use the positional indexing. Let's say we want to change the first 3 elements to 10. Okay, we want them all to be the same number. So for this, we're going to do series of 0 to 3. Because remember, 3 is not included. And we're just going to set this equal to a single value of 10. Okay, so you can see that this changes all of them to be the same value, in this case 10. So this is absolutely allowed. We can assign a scalar value to this range, and it will change all of the values in that range to this whatever we're changing it to. However, we might want these to be 3 different values. For example, let's say we wanted 11, 12, and 13 instead of 10. Well, for that, we can do the exact same setup, so 0 through 3, but instead of changing it to a single value, we're going to pass in a list of values, so 11, 12, and 13. And that's absolutely allowed. You can see that the first 3 values have changed. Now, there are some restrictions here, and namely, those restrictions are that if you're passing in a list, it has to be of the same length as this slice. So this is 3 elements. We need to make sure there are 3 elements in this list. We cannot do this. Okay, we'll try and do that. That's not allowed. Nor can we do something like this. Okay, so that's too many elements. The previous one was too few elements. We have to make sure that it is of exactly the right size. Okay, so this is, let's say something like list has to be of the same length as the slice. Okay, so we need to make sure that we have the same number of elements there and there, unless we are using a scalar value, in which case we can propagate that value throughout all of these. Alright, so that's how you'd go about modifying elements within a series. However, sometimes you'll want to modify the structure of a series, specifically to kind of shuffle things around or to rename your labels or something like that. Now, the first thing I'm going to take a look at is going to be the renaming functionality. Okay, if you remember our series, we'll just go ahead and print out series here, will look like this. There was a name attribute which we didn't fill in. The default name attribute is just going to be an empty string. If we did want to assign a name to the series, we can use the rename function. So we can just do series.rename, okay, and we'll just call this something like series1. So not very interesting, but that's fine. Now when we go to run this, you can actually see the changes are not reflected, but this is assigning the name to the series. Now that's not super useful, but an interesting thing occurs when we use our rename function with another function as its parameter. So if we're not passing in just a single string value, what this will do, the rename function, is it will actually rename all of the labels. For example, let's say I wanted to convert each of these labels to an uppercase letter instead of keeping them as the lowercase letter. For that, I can do series and then my rename function again, but what I'm going to do is I'm going to say string.upper. Okay, and the changes are not being reflected because we're not actually reassigning it to the new series. So both of these operations will actually return a new series. So that's kind of why things weren't being changed. We'll run that. Now you can see that the name is being assigned there. Okay, and then if we do this again, series is equal to series.rename string.upper, then you should see the changes reflected. Okay, good stuff. So you can see that these have all been changed to uppercase. Interestingly enough, if you pass in a function, it will apply that function to each of the labels. If you pass in just a single string value, it will rename the entire series. Okay, so just kind of something pretty interesting there. The last thing I want to talk about is the reindex function. So if you remember, I think that was back in... Actually, I think that was a few sections ago when we did something like this, when we were reshuffling or shuffling our series to kind of reposition everything. We saw that we could actually add in other items, such as an F or a G or an H. We could add those extra indices in, and for now, it was okay with that. But it did say in future versions of Pandas that is not going to be allowed. Well, we can do that exact same thing in a way that will be allowed with the reindex function. The reindex function allows us to basically do exactly the same thing, kind of shuffle things around, but we can also add in new indexes. So let's say we want a new series. Actually, we'll stick with the same series. We'll have to reassign it because once again, this is going to return a new series. So we'll say series.reindex. Okay, and let's say we just want to shuffle things around a bit. Remember, we're now dealing with uppercase indices, so that's why the regular lowercase indices won't work. So in this case, we just want to kind of shuffle things around a bit. Let's do something like, no, we'll start with B, then A, then E, then C, then D, something like that. Okay, we'll go ahead and print out the series. You can see that things are now kind of shuffled around. Now, the main benefit, again, to using the reindex rather than just that way up there is going to be that you can add in additional labels. So let's say we did the same reindex, but now we're adding in F. We're adding in, I don't know, Z for whatever reason, if we want to add in a completely new label there. So now you see there is no error or no warning, so it's totally fine to do. And we've added in 2 new labels. Now, we haven't assigned values for these labels, we've just added in the indexes. So this is basically going to fill them in with not a number because the overall type of this is going to be a float 64. Let's say we had series as a different type. So maybe at some point in time, we reassign this to be some sort of string. Okay, and actually, you know what I'm going to do? I am just going to reassign it down here. So we'll say series of, I don't know, 0 is going to be equal to some string. Okay, and I guess it's not going to like that key, so let's do series of A. Okay, so now the data type is an object, but we have still kept these as not a numbers. So you can see that the default behavior here when we're adding in new labels is just to put in some kind of value that's not a number. It's not going to fill it in with none or null or anything like that. It's just going to fill it in with not a number, even if the overall type is an object. So I'm actually just going to get rid of that. I'm just kind of wanted to point that out. That is going to be consistent throughout all of these label additions. Okay, otherwise that is, I think, pretty much all we wanted to cover in this section. So the focus was mainly on modifying elements here. We saw how to modify individual elements based on position or on label name. We can assign a scalar value to multiple indexes or assign multiple values to multiple indexes. It's just as long as we have as many new items as we have indexes that we're accessing. We can rename an entire series or rename each of the labels. We can shuffle things around and we can even add in new labels, and it fills it in with not a numbers as defaults. So when we come back in the next section, we're going to be working on series operations. This will be, for the most part, a bunch of arithmetic operations, although there'll be stuff like type conversions, sorting, and applying functions to the values. Okay, so stay tuned for those. Thanks for watching. I'll see you guys in the next one.